Thermite is composed of a metal oxide and a metal, in this case, iron oxide and aluminum.
To demonstrate the thermite reaction, we struck an aluminum-covered ball against a rust-covered ball to create sparks.
Now here's the full demo of the thermite reaction. Here, a magnesium starter is ignited in a Bunsen burner flame. The igniter is placed into the cup of thermite. Once the reaction starts, the fume hood is closed and the fan is turned on. Here you can see the molten iron dripping through the copper bowl. You can see how exothermic the reaction is. In the sand, you can see the molten iron solidifying. Look how hot the iron bowl is getting. Here you can see the hole that the molten iron caused in the copper bowl.
This is the results of the reaction. Here is the unreacted thermite and some of the molten iron. And the majority of the molten iron and aluminum oxide is down there.
Thermite is the pyrotechnic composition of a metal powder and a metal oxide.
Thermite reactions are extremely exothermic. Thermite is generally made with aluminum powder and iron oxide. Thermite has a very high activation energy.
Some common reducing agents for thermite are aluminum, magnesium, titanium, zinc, silicon, and boron. Some common oxidizing agents are boron-3 oxide, silicon-4 oxide, chromium-3 oxide, iron-2 oxide, iron-3 oxide, copper-2 oxide, lead-2, 3, or 4 oxide.
Thermite's high activation energy requires unconventional means to start the reaction. The two most common ways to ignite thermite are by burning magnesium ribbon or by using the heat from the reaction between potassium permanganate and glycerin.
There are two different mixtures of iron thermite. The first is hematite, which is the reaction between iron-2 oxide and aluminum. The change in enthalpy when the products solidify is negative 3.985 kilojoules per gram. This is the reaction that took place in our demo. Iron-3 oxide, also known as magnetite due to its magnetic properties, also reacts with aluminum. The change in enthalpy when the product solidifies is negative 4.584 kilojoules per gram.
The reduction half reaction for hematite is on the slide.
In the oxidation half reaction, each aluminum loses 3 electrons. Here's the complete redox reaction for thermite.
The thermite is caught in a bucket of sand because sand can easily absorb the heat from the molten iron due to its high heat capacity.
We'd like to say thanks to ourselves for making the video.
And thanks Mr. Antrim for providing us the supplies and some ideas.
Bloopers! Thermite is generally made with aluminum powder and iron oxide. Termite.
Shut up.
Okay. Do that.